Hello and welcome to a lesson on binomial expansions. In this lesson we'll be expanding a bracket with two terms to any positive integer power, and we'll be using two techniques. First we'll use Pascal's triangle, and then we'll use what's known as combination notation. To begin, we'll first consider a plus b squared, a plus b cubed and a plus b to the power 4. And I'm going to multiply these out manually so we can see what patterns emerge. To begin then, a plus b squared. That's equal to a plus b multiplied by a plus b, and if we multiply that out, we get a times a is a squared, a times plus b is plus ab, plus b times a is plus ab, and plus b times plus b is plus b squared. Now we can collect like terms together, so I can collect the ab and the ab to give 2ab. So that gives us a squared plus 2ab plus b squared. Now what about a plus b cubed? Well, that's a plus b squared multiplied by another a plus b. So I'll begin by writing down what we've just found. A squared plus 2ab plus b squared multiplied by a plus b. Now I'll first multiply this bracket by the a, and that gives a cubed plus 2ab times a is 2a squared b, and a times b squared is plus ab squared. Now I need to multiply the first bracket by the b. Plus b times a squared is plus a squared b, plus b times 2ab is plus 2ab squared, and plus b times b squared is plus b cubed. I think it helps to write things down, write in like terms underneath each other, because then it makes them easy to collect together. We've got a cubed, and I've got 2a squared b plus another a squared b is 3a squared b, plus ab squared plus 2ab squared is plus 3ab squared, and finally we have b cubed. So we've now got a plus b all cubed. Now let's look at a plus b to the power 4, which is what we've got already, multiplied by another a plus b. Right, I'm first going to multiply the first bracket by the a, and then I'll multiply it by the b. So that gives us a times a cubed is a to the 4. A times plus 3a squared b is plus 3a cubed b. A times plus 3ab squared is plus 3a squared b squared. And a times plus b cubed is plus ab cubed. Now let's multiply the first bracket by the b. Plus b times a cubed is plus a cubed b. Plus b times 3a squared b is plus 3a squared b squared. Plus b times 3ab squared is plus 3ab cubed, and finally plus b times b cubed is plus b to the 4. Now collecting like terms together, that gives us a to the power 4 plus 3a cubed b plus another a cubed b is 4a cubed b, and we've got 3a squared b squared plus 3a squared b squared, giving a total of 6a squared b squared. And the next one, ab cubed plus 3ab cubed is plus 4ab cubed. And finally we've got plus b to the 4. Now let's have a look at how many of each term we have in each expansion. Here we see that I've got 1a squared, 2ab's and 1b squared. When we're looking at the cubes, I've got 1a cubed, 3a squared b, 3ab squared and 1b cubed. And on this bottom line I've got 1, 4, 6, 4, 1. They're what are called the coefficients of the binomial terms. Coefficient means how many you have. Look at the powers and you'll see each term, the total power is the same. So we've got a to the power 4. Here I've got a cubed b, which I can think of as a cubed b to the 1, a squared b squared, a to the 1 b to the 3 and b to the 4. So in each term the total power of the two letters adds up to 4, which is the power we're expanding the bracket to. Similarly here, 3, 2 plus 1 would be 3, 1 plus 2 would be 3 and 3. Now then, fortunately a mathematician called Pascal developed a triangle that will find these numbers for us, and that's what we're going to look at now. Now let me begin by reminding you of the coefficients we found on the expansions on the previous page. When we had a plus b all squared, we ended up with 1a squared, 2ab and 1b squared. When we looked at a plus b all cubed, we had 1a cubed, 3a squared b, 3ab squared and 1b cubed. And what Pascal discovered was that if we look at this line and we add those two numbers, it gives us the 3, and if we add those two numbers, it gives us the 3. And if we keep going with that pattern, it gives us the coefficients for any integer power of the bracket. So to get the next line, I first put the 1. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. And then I need a 1. And you'll recognize those perhaps from the previous page. Let's go back. 1, 4, 6, 4, 1. And we can keep going. If we want a plus b to the power 5, the coefficients will be 1. 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5. And then we get a 1. Now in a textbook you may well see a 1 up there to complete the triangle, but it doesn't actually have any meaning. Let's do one more row. 1. 1 plus 5 is 6. 5 plus 10 is 15. 10 plus 10 is 20. 10 plus 5 is 15. 5 plus 1 is 6. And then the 1. And in an exam question on binomial expansion, this is the kind of thing you'll have to write down. Let's have a look at our first example. Let's expand a plus b to the power 5. Well, this is the line that gives the power 5 because it's got the 5 in it. So it should be a to the power 5, one of those, plus 5, a to the power 4 times b, plus 10 a cubed b squared. See what's happening here? The power of a is going down 1 each time and the power of b is increasing 1 each time, so that the total power is 5 all the way along the line. So I've had that 10, I've got another 10 now. 10 a squared b cubed plus 5 a times b to the power 4. And finally we've got 1b to the 5 on its own. And so that's the expansion of a plus b to the power 5. Let's have a look at another example, a plus b to the power 6. Well, this is the line for the expansion of a plus b to the 6. We know because it's got the 6 in it. So we end up with a to the power 6 plus 6 a to the power 5 times b plus 15 a to the power 4 times b squared plus 20 a cubed b cubed plus 15 a squared b to the power 4 plus 6 a times b to the power 5 and plus a single b to the power 6. So look at the symmetry there between a and b. You've got a to the 6 on this end, b to the 6 on this end. You've got 6a to the 5b, 6ab to the 5, and so on, working your way towards the middle. Now let's move on to example 3. This is more like a typical exam question. 2 plus 3x all cubed. So if we're going to cube something, I want the line of coefficients with the 3 in it. 2 is our a, 3x is our b. So what we want is 2 cubed plus 3 lots of 2 squared, good idea to keep it in brackets, multiplied by 3x to the power 1, plus another 3 for the coefficient, 3 times 2 to the power 1 times 3x squared, plus 3x cubed. So that matches the patterns we had when we were dealing with a's and b's. It's like a cubed plus 3a squared b plus 3ab squared plus b cubed. And now we've got to simplify this. So 2 cubed is 8. Here we have 3 times 2 squared. 2 squared is 4, 3 fours are 12. Multiplied by another 3 is 36x. Plus, careful here, this is 3x all squared, which is 9x squared. So I've got 9 times 2 is 18, times 3 is 54. So I've got 54x squared. And finally, plus 3x cubed, 3 cubed is 27, so it's plus 27x cubed. Example 4. 2 minus x to the power 5. The best way to think of this is 2 plus minus x to the power 5. Putting the minus x in a bracket will ensure that we keep the correct signs all the way through the expansion. So now I'm going to use this line here, the one with a 5 in it, because we want the power 5. So it's 2 to the power 5 plus 5 times 2 to the power 4 multiplied by minus x. Moving along, we now need the 10. 10 times 2 to the power 3 multiplied by minus x squared plus 10 2 squared multiplied by minus x cubed plus 5 times 2 times minus x to the power 4, and finally plus minus x to the power 5. Now simplifying, 2 to the power 5 is 32, and we've got one negative in this multiplication here, so that's going to be a negative answer. 2 to the power 4 is 16, 16 times 5 is 80, so we've got minus 80x. Now the next term, we've got a minus x squared, so that's two negatives multiplied together give a positive. And we've got 2 cubed is 8, times 10 is 80, so that's plus 80x squared. Now we've got 3 negatives multiplied together when we cube that term, and so that's a negative overall. 2 squared is 4, times 10 is 40, so that's minus 40 x cubed. 4 negatives multiplied together here makes the term positive, and 5 times 2 is 10, so that's 10x to the 4. And finally, 5 negatives multiplied together is negative, so it's minus x to the power 5. So what we find here is the signs alternate. Positive, negative, positive, negative, positive, negative. And that will always happen when you're expanding a term like this to an integer positive power. If there's a minus sign between the two terms, the signs will alternate. If there's a plus sign between the terms, all the terms will be positive. And that brings us to the end of the first part of this lesson. We'll now move on in the second part of the lesson to look at how we can find terms in a binomial expansion using combination notation. First of all, we'll have a look at what combination notation actually means. So it's about the number of ways of choosing R objects from n, and there are 3 ways this can be written. It can be written as n choose R, one number above the other, or it can be written as NCR, often pronounced n choose R, or in some textbooks it will be written as NCR like that. But in each case, these mean the same. They mean n factorial divided by R factorial multiplied by n minus R factorial. But what's a factorial? Well, n factorial simply means n times n minus 1 times n minus 2 times all the way down every integer 3 times 2 times 1. So for instance, 6 factorial means 6 times 5 times 4 times 3 times 2 times 1. So that would be 1 times 2 is 2, 2 times 3 is 6, 6 times 4 is 24, 24 times 5 is 120, and 120 times 6 is 720. So 6 factorial would be 720. We also define naught factorial to be equal to 1. Because if we didn't, when we're using this fraction here, we wouldn't be able to get an answer when we're choosing n objects from n objects, because we would have 0 factorial, and to make sense that needs to be defined to be 1. So let's have a look at some examples. We'll begin with 5c2. The number of ways of choosing 2 objects from 5, and that's given by 5 factorial divided by 2 factorial multiplied by 3 factorial. Here the r is 2, so we've got 2 factorial, and the n minus r is 5 minus 2, which is 3, so we've got 3 factorial. Now we can write that out as in full as 5 times 4 times 3 times 2 times 1 divided by 2 times 1 multiplied by 3 times 2 times 1. And you can see I've got just as many numbers on the bottom as I have on the top. Now there's a lot of cancelling to do. The 3, 2, 1 on the top, knock out the 3, 2, 1 on the bottom. They all become 1s if you like. And I can cancel the 2 into the 4, goes in twice. So I've got 1s all the way along the bottom now, and on the top I've got 5 times 2. So it's 10. The number of ways of choosing 2 from 5 when the order doesn't matter is 10. A second example, 7 choose 5. Well, this is equal to 7 factorial over 5 factorial times 2 factorial. The 7 minus 5 giving you the 2. Now I could write it all out in full like that, but there's no need, because this will be 7 times 6 times 5 times 4 times 3 times 2 times 1, but the 5 factorial will cancel out the 5, 4, 3, 2, 1. So I just need to write the 7 times the 6. And we often use dots for multiplication when we're dealing with factorials. So I won't put the 5, 4, 3, 2, 1, but I won't put it on the bottom either. So I won't write 5, 4, 3, 2, 1 there. So the only thing I'm going to divide by is 2 factorial, which is 2 times 1. So 2 will cancel into 6 3 times. And on the top I've got 7 times 3, and on the bottom I've just got 1. So that comes to 21. And our final example, we'll look at 6 choose 6. Well, how many ways can you pick 6 out of 6? Only one. But it still fits the formula because this would be 6 factorial divided by 6 factorial, and 6 minus 6 is 0 factorial. But we defined 0 factorial to be 1. So this is just 6 factorial over 6 factorial times 1. And we can cancel by 6 factorial to get the answer of 1. Now, how good do you need to be at manipulating these combinations manually? Well, that depends on which syllabus you do. If you're doing, for instance, the MEI syllabus at A level, then this topic comes on Core 1 and you're not allowed to use a calculator. So you need to know how to do this. On the other hand, if you're doing the EdXL syllabus, this comes on Core 2 and you can use your calculator, and every scientific calculator should have a button that allows you to work out combinations. It'll be called NCR. We'll now put this into practice. We're going to use combination notation to find a single term in a binomial expansion. And we'll look at 3 examples. Calculating coefficients. Find the coefficient of x squared in 1 plus 2x to the power 10. Now the coefficient simply means how many x squareds there are in that expansion. Now imagine those 1 plus 2x brackets are written out side by side, 10 of them. When you multiply them all out, each term will have something from each of the 10 brackets. So it'll have some 1s and it'll have some 2x's. But the terms in x squared must have 2 lots of 2x and 8 lots of 1 from the 10 brackets. But how many ways could we pick the 2x from the 10 brackets? Well, if we want 2 of them, there's 10 choose 2 ways of selecting the 2x. And that's why the combination notation comes into the expansion. So the term in x squared is given by the number of ways I can choose 2 from 10, 10C2, multiplied by, and I want the 2x, 2 lots of it, so it'll be that squared, multiplied by 1 to the power 8, because I'll need 1 from 8 brackets. And we simply have to work this out now. 10C2 is equal to 10 times 9 over 2 times 1, because it should be 10 factorial over 2 factorial, 8 factorial. But again, the 8 factorial on the bottom knocks out 8, 7, 6, 5, 4, 3, 2, 1 on the top. 2x all squared is 4x squared, so I'll write in there multiplied by 4x squared, and of course 1 to the power 8 is just 1. 2 goes into 10 5 times, so that gives me 5 9s are 45, and 45 times 4 is 180. So that's 180 x squared. Now the coefficient, the amount of x squareds I have, is 180 of them. So the answer is 180. Moving on to example 2, find the coefficient of x cubed in 2 minus x to the power 8. Well, if we're going to look for terms in x cubed, in these 8 brackets we'll need to be taking the minus x in 3 of them to get x cubed, and we'll be taking the 2 in 5 of the brackets. Well, how many ways can we choose the 3 lots of x out of the 8 brackets? It's 8 choose 3. So the term I'm looking for is 8 choose 3 multiplied by, and I want 2 to the power 5, because I want 2 from 5 of the brackets, and minus x cubed. And as in the other binomial expansions we've looked at, notice that these two numbers here add up to 8, the power of the expansion. Now 2 to the power 5 is 32. Minus x cubed, well, you've got 3 negatives, so it's going to come to minus x cubed. What about 8c3? Well, 8c3 is 8 times 7 times 6 divided by 3 times 2 times 1. Remember, it's 8 factorial over 3 factorial, 5 factorial. But the 5 factorial I'm using to knock out the 5, 4, 3, 2, 1 on the top. So I can say 3 times 2 is 6 on the bottom, cancels out a 6 on the top. So I've now got 8 times 7, which is 56, times 32, times minus x cubed. Well, let's pretend we're doing the MEI syllabus. We've got no calculator, so I need to do the long multiplication, 56 times 32. 6 2s are 12, carry the 1, 5 2s are 10 and 1's 11. Add a 0, 6 3s are 18, carry the 1, 5 3s are 15 and 1's 16. Add them together, 2, 9, 7, 1. So this comes to 1792, but remember the term's going to be negative. So I have this is equal to minus 1792 x cubed. That is the term in x cubed. If I'm asked to find the coefficient, that's simply asking how many I have. So the coefficient is minus 1792. Moving on to our final example. Find the coefficient of x squared in 1 plus 2x to the power 20. Well, if I want a term in x squared, I'm going to want 2 lots of the 2x out of the 20 brackets. How many ways can I choose them? 20c2. And then I'm going to want the 2x squared, so that means I'll have the 1 to the power 18. But that's 1 anyway. So this is 20 times 19 over 2 times 1. It should be 20 factorial over 2 factorial, 18 factorial. But I can use the 18 factorial to knock out the 18, 17, 16 all the way down to 1. This is multiplied by 2x all squared is 4x squared. And that's multiplied by 1 to the power 18. If I cancel by 2, that'll give me 10 there. So I've got 10 times 19, which is 190, multiplied by 4. So 190 multiplied by 4 is 760. So this is going to be 760 x squared. And again, if I'm asked to find the coefficient, I simply say that the coefficient, the amount of x squareds I have, is equal to 760. And that completes this lesson on binomial expansions. There's an exercise for you to try now, which will give you examples on both of the types of question we've been answering in this lesson.